distinguish between proportional, proportional, and non-proportional
Situation.
situations using tables, graphs, and equations.
Alright, so first, solve problems involving direct variation. Now we got a math term up there, direct variation. That's a new word. That's a new word that we're learning, direct variation. Alright, direct variation, Jermaine. Direct variation is a relationship between two variables. Dinar? It's a relationship between two variables, x and y, that can be written in the form y equals kx. We're in the direct variation. See that math term on the left?
Yeah, but I don't know what they're talking about.
That's what we're about to talk about. I'm trying to read the definition for you first so we can get understanding. Alright, so a direct variation is a relationship between two variables, x and y, that can be written in the form y equals kx, where k is a constant other than 0. Alright, now, our normal equation that we've been working with was the slope-intercept form, which is y equals mx plus b. Okay?
I get that.
Now, with the direct variation, we have y equals, and they're using the variable k, which that can also be considered m. Alright?
So K is the slope.
K is the slope.
Okay.
Okay, so we think about k, we think about m. Alright, so y equals mx
So K.
would be a direct variation equation. So the constant has to be what? The constant has to be a number what? What does it say?
The constant other than 0.
0, other than 0. Alright? So the constant is a number other than 0, but the y-intercept, which is always the what?
Start.
Start. It's always the starting point. So the y-intercept is where it's going to always start when you have direct variation. So that means, notice that this equation doesn't have a y-intercept in it, does it?
No.
And remember what we said, there's no y-intercept mentioned and the value is 0. Okay, so anytime it's direct variation, that's how the equation is going to look. And it's going to be linear. Alright? Yes.
So, okay. How it says the form of y equals kx, does that mean slope and variable, or the x is something else?
The x is whatever the situation is, that's what's being plugged in. But the rate of whatever's happening is the slope. Okay? So if it's money per hour, like we dealt with in the last lesson when we talked about the amount of money that the lifeguard was making per hour. Alright, one of those equations was a constant, and one wasn't. Which one was it? Remember the lifeguard made how much? Yes.
And how many hours?
The lifeguard. How much did the lifeguard make?
Made $10
She
plus
made-
2.
She made $10 plus 2.
$2 per hour though,
Yeah,
right?
$2 per hour.
Plus 10. Right.
Yeah.
To Marcus. How much did the umpire make to Marcus?
Sir?
How much did the umpire make in the last lesson?
55.
No. In the last lesson, how much did the umpire make?
Two.
No, $4 per hour was what she made. Alright? So, which one of those, based on the definition, we talked about direct variation, which one of those would be considered the constant in the direct variation? Which one would be a direct variation equation? Y equals 2x plus 10 or y equals 4x?
Y equals, huh?
Which one would be a direct variation equation? Yes.
Y equals 2 x plus 10.
Alright, what does direct variation equation look like?
Oh, I mean, no. Y equals 4x.
Y equals
My
4x.
bad.
Doesn't have that y-intercept.
Because it don't got that y-intercept, like
Right.
you said.
Because it said direct variation is a relationship between two variable x and
Y that it
Y
cannot be written in
it cannot
form.
be written in form y equals kx.
Because it don't got the
K is
y-intercept.
any constant
Right.
other.
So make sure you're writing that example
So
in the note section.
the y is gonna always be
Direct
0.
variation.
Y always be 0. Y-intercept will always be 0.
Yeah.
Not the y variable, y-intercept.
Okay.
Alright, so in this example, hold on for a second, let's go over this example.
Alright.
Alright, to relate time and distance for a car traveling at 55 miles per hour, the equation is d equals 55t. Alright, substitute values for t to use the direct variation relationship. What is the relationship between d and t? So it tells you, what does step 1 say? If T is 2 hours, the distance traveled will be 110 miles. How did they get that?
Oh,
Yeah,
Wait.
man.
they multiply 55 times 2, I think.
55 times 2, because they use the equation
Oh,
where distance equals the miles times the time, all right, which is T. So all you have to do is plug in the 2 into that equation and get 110,
yeah,
all right?
you're right.
Now the time is doubled, so they said the time was doubled. So that's 4 hours instead of 2 hours. How much would it be to Marcus? The time was doubled. 16? So if you plug 4 into that equation, D equals 55T. You have to multiply 4 times 55. Andrew, what would it be? It's actually in the book, step 2. Get step 2. $220. All right, 220. All right. So when the value of T is doubled, the value of the distance traveled is doubled. The variables of D and T are directly proportional. The value